This is problem E on diagramming interactions and forces. And what you just saw was the soccer puck sliding across the view, moving on a horizontal surface. And we're assuming that friction is negligible because it is riding on a cushion of air, which pretty well does away with the friction force that it would have between the bottom of the puck and the table. And also it's not moving very fast, so there's not much of a force of air resistance on the sides of it. So go ahead and start with your system schema diagram and pause the video and then come back and check what you have. So my objects are the puck, and I have the table and the earth and air. And thinking about the interactions, I would say that the puck is interacting through the gravitational interaction, being attracted to the earth. And it's kind of riding on a cushion of air, so I don't actually think the puck is interacting with the table at all. It's not touching it, but it is interacting with the air. And because the puck is kind of squeezing those air molecules, I would say this is a scrunching kind of an interaction where those air molecules are being compressed and trying to expand, pushing upward on the puck, and then the puck is pressing down on those air molecules. So these are all of my interactions. Now I'm ready to draw the free body diagram. So we represent our focus object, which I'm circling with a dotted line. You know the focus object because it's in bold over here. Represent the focus object as a dot over here. And then we're going to draw all the forces on the object. So each interaction produces a force. So I can see I have two interactions, two lines that cross my dotted boundary. So that means I'm going to have two forces over here. So let's start with this one, the force of the earth on the puck. That's a gravitational force. And then we need to label each force. So this is the force of earth on the puck. If you want to, you can also indicate that is gravity. And that takes care of this one. And the second force we have is the force of the air. And here what we're talking about is the air underneath it that is trying to expand upward. And that air is pushing upward. That's a scrunching force. So this is a force of air on the puck. And that is a scrunchy kind of a force. Now, doesn't it seem like there should be some more forces? I mean, it's moving to the right, so we tend to think it needs some kind of a force. But if we look at our interactions here, there is nothing it's interacting with that could be pushing it to the right or to the left. So there are no horizontal forces in this situation. You say, well, does it have, what about its momentum? Well, it does have momentum. We'll learn what that word means later, but it's moving. It has a speed, but that is not a push or a pull. So there are actually no horizontal pushes or pulls on it. It's just moving, and there aren't any horizontal forces on it.